Hello there. My name is Haley. My partner Sierra and I study the physics of bubbles. Today we will discuss the history and how waves and forces act on the bubbles, along with real-life applications of this information.
The history of bubbles began with the early Phoenicians. Around 600 BC, they boiled animal fat and ashes to make a soap-like substance. By the 1500s in France, soap was now commonplace, but the first recorded instance of bubbles being used as a toy was found in a 1587 French woodcut that showed people chasing bubbles in a courtyard. In the 17 and 1800s in America, mothers gave their children leftover washing soap and straws to blow bubbles in for fun. Yet it wasn't until the early 1900s that pitchmen and peddlers began to sell bubbles as a toy. In the 1940s, ChemToy, a cleaning supply company, was the first to package and sell the bubbles directly to the public. Since then, bubbles have remained a classic toy, but we have had a couple innovations. We've gone from just stick wands to having battery-operated blowers, and we also have options like colors and scents for our bubbles now. Even so, this will always be a great toy to play with. One of the coolest things about bubbles is its colorfulness. This iridescence is caused by the structure of the soap bubble. Essentially, it has a film of water surrounded by, on both sides, soap molecules. When light hits a bubble, some of the rays will instantly bounce off the outer soap layer, while the rest of the rays will go through the water film and bounce off the inner soap layer. This difference in timing of the rays going back out of the bubble will create an interference of the waves. The interference can either be constructive, which would increase the intensity of the color, or destructive, which would make the bubble almost see-through. This interaction of light waves is comparable to beats in sound waves. Either way, it creates a really cool effect when looking at bubbles.
When it comes to the bubble's shape, surface tension is the one to thank. Due to this force acting upon the soapy substance, the bubble will form only in a spherical shape, even if blown through a non-spherical wand. This is because of the pressure difference inside and outside of the bubble. A force like this can be visualized like two hemispheres, and noticing the internal pressure pushes the hemispheres apart. This is counteracted by the surface tension acting upon the circumference of the circle.
And these concepts can help you do more than just learn physics. Knowing about surface tension can help performers who do bubble art. Kids can always be amazed by seeing how colors interact when they're little. And maybe someday we'll be able to have bubble travel like in Meet the Robinsons.
Hi. Oh, hello there. Oh, I didn't see you there. I got bubbles for sale. I got red bubbles, blue bubbles, iridescent bubbles. I think this was the soapy end. Okay. It was a soapy end. Oh. Hakuna Matata. Hakuna Matata.